So
This meeting is being recorded.
let me welcome everyone to this Polycon Ukraine webinar that we are going to have today. Today we are going to have Arda Gitmez from Bilkent. He's going to present polarizations and media bias, and this is joint work with Pooya, Molavi. Our format is, as always, the same. We have 1 hour of the presentation, and that also includes a Q&A session towards the end, about last 10 minutes. But Arda is okay with people asking questions and muting themselves during the talk. So if you have any pertinent question, please ask directly, and we'll manage the time as we go. I think Pooya is not going to join us today, so we are going to monitor the chat. Please ask questions there, but we might as well ask Arda directly. Just to remind everyone, next week, sorry, in 2 weeks, we meet every 2 weeks. In 2 weeks, we have Gianmarco Leoncilota from UPF talking about policymaking, trust, and the demand for public services evidence from nationwide family planning program. So that's in 2 weeks. Meanwhile, Arda, floor is yours.
Thank you very much. It's a great pleasure to be a part of this seminar series. So thank you very much for the invitation as well. So as Max told, this is joint work with Pooya. And the title of the paper is Polarization and Media Bias. So as you might expect, I'm going to start by giving some motivation about polarization and media bias. I'm going to do it in reverse. I'm going to start with the media bias, and then we're going to come to polarization. So, okay. So here is a fact that has attracted a lot of attention recently, both empirically and theoretically, but the papers that I'm citing here are empirical papers. The mass media is becoming more and more partisan over time. And, you know, okay, it's a worrisome thing, but on the other hand, if you think about it, people are still paying attention to these media sources, even though they are partisan. And it's not super surprising, because if you are just leaving this entertainment aspect of media aside, if you are following media for the sake of obtaining information, even when you are faced with partisan media, you might still be receiving some information, however little it is, right? And therefore, you know, you might still benefit from paying attention to the media. And of course, this is a strategic choice. It's not, you know, a foregone conclusion for everybody. But what I want to point out is that paying attention to the media is a strategic choice that depends on a bunch of factors. It depends on individuals' initial opinions, like how strong you feel about the issues that are being discussed. It depends on individuals' attitudes, right? So how strongly your preferences are about these things. It also depends on the media's bias, media slant, right? And here is where it becomes a little bit interesting, because of course, individuals are not the only strategic actors in this landscape. Media is also strategic, so it's setting its slant strategically, right? So, and this creates an interesting feedback loop, because the media slant, of course, then depends on the people's distributions of opinions of attitudes, right? So these things that determine the choice to whether to follow the media or not also in turn depends the media slant, right? So from here on, let's start discussing about distributions of opinions and attitudes, and you can imagine where I'm going with this. These things are becoming also increasingly polarized over time, right? It's also a phenomenon that attracted a lot of attention, both theoretically and empirically. What I want to point out here is that this polarization has consequences, of course, about who follows these news sources and who does not. Especially if you just think about the slide that I just shared. Just think about 2 types of people, right? So you can think about moderates, and then you can think about the extreme individuals. And in a manner that I'm going to formalize later in this talk, you can imagine that the moderate people are actually those that are hungry for information, right? Because you are a moderate, even little bits and pieces of information can affect your decisions. So you are more inclined to follow the news sources as long as they provide you some information. On the other hand, if you are an extremist, if you hold very firm priors, very firm opinions, or very strong attitudes about policies, you might just disregard these policies because you realize that it's not going to affect your actions, right? So now what does polarization do? Well, on a basic level, it takes some moderates and it turns these people into extremists, right? So it sort of shrinks the media's available base. So, and in return, as I already discussed, it changes the media's policy, right? So now in terms of the partisan media, we face a problem, right? So if you're strategic in your slanting choice, now you have to decide who you are targeting. Are you targeting the moderate people or are you targeting these extreme people? And if you are targeting the extremes, what part of the distribution are you targeting? It's a question that you are facing. And what level of slant to set, right? So are you gonna induce a lot of bias and just attract these moderate people, or are you gonna be super informative and are you gonna attract the extremes, right? So these type of questions are affected by the polarization of opinions, and this is the question that we're going to study in this paper, right? So how does this partisan media choose its slant, and how does the partisan media choose whom to target, and how do these decisions depend on the polarization, change with the polarization, right? So what I'm going to do today is that I'm going to present you a model of a partisan media making this choice. The partisan media is facing a sophisticated and heterogeneous audience, sophisticated in the sense that people are strategic, they understand that the media is biased and etc. And they are heterogeneous in their opinions and attitudes in a manner that I'm going to describe. So the partisan media chose the slant, but people are sophisticated and know this slant, still they make the decision to strategically observe the news or not. Therefore, the set of citizens who follow these media is endogenous, right? So the partisan media cannot force people to watch these news. So effectively, it chooses whom to target, right? So the questions that we are going to ask is just like the questions that I gave. Who do you target? And how does the policy, how does the bias change with the polarization, right? So these are the two answers that I'm going to provide today. In the paper, we ask somewhat somewhat other questions as well. We talk about, like other changes in the distribution, but given the time constraint, I think this is going to be enough to get us going for today. Now, here are the short answers that I'm going to provide. We can talk about the intuitions and how they come up later, but just as a very brief overview of results. How does the partisan media target? Who do you target when setting your policy? It depends on the distribution of opinions and attitudes. In particular, if you are talking about a unimodal society where these distributions and opinions are more or less coherent, right? A monolithic society, then the partisan media just goes ahead and targets the supporters that are people who are more inclined to support this policy to begin with. If you are facing a highly polarized electorate, which is like two blocks of citizens, then you go into the other direction, which is like, slightly counterintuitive at this point, but we are going to talk about this. And the second finding is that how does the media bias change with the polarization? The answer is that, again, somewhat counterintuitively, polarization actually tends to reduce the media bias. So essentially, what polarization does is that it creates a lot of extremists who are not sort of inclined to follow the media unless it's super informative. And then it creates a force towards media in order to reach out to these citizens, right? So that's like the basic dynamic. So this polarization in terms of media bias has this like unexpected moderation effect, I would say, right? So we are going to talk about how it comes out and what I mean by polarization and etc. We're going to formalize these intuitions later. But I think it's going to be much, much easier once I present you the model. So let me just jump into the model. Here is this obligatory literature review slide. It's very crowded, so I'm not going to spend a lot of time on it. There are three papers that I highlighted here. So the first one is that this moderating effect of polarization. Theoretically, there is one more paper that I know of. It's this Oliveros and Vardy paper, Economic Journal. So there they have this like observation that under certain conditions, a polarization of the electorate might actually induce people to follow more moderate news sources. I tend to think of their explanation as like a demand side explanation. Here we are thinking about more like a supply side of this issue. So that's like the main difference. And I already gave you some hints. The media is going to set up a slant and it's going to be observable to people. So technically, what I'm going to present is a model of Bayesian persuasion. Sorry, for some reason, oh, yes. So I'm going to present a model of Bayesian persuasion, right? So so it's going to be a Bayesian persuasion model towards an audience with heterogeneous characteristics. And we are going to do some comparative statistics with these characteristics. I think the closest approach that we see is this Kolotilin, Milovanov, and Zepachelnik paper that's been recently published in TE. They also give some comparative statistics, but they are not in terms of the polarization of the electrode. So that's like the relatively new part. And then we are going to have these like heterogeneous opinions, which is going to be captured by the assumption of heterogeneous priors in our model. I keep having problems with this. I'm sorry. Yeah. All right. So let's get to the model. So I did an amazing thing last night, and I was able to fit everything about the model within one slide. So this is going to be everything that you need to see. I think it was like a great achievement. So there is going to be a state of the world, right? So this is a strategic communication model. So there is a sender and there is a bunch of receivers. So the sender wants to send an informative message about the state of the world. I'm going to assume the state of the world to be binary. If theta is equal to 1, it means that the partisan media's preferred platform is actually good for the people, right? So if everybody knew that theta was 1, everybody would agree on this policy, theta 0 otherwise. So there is a group of receivers. I am going to normalize their measure to unity. Each of these receivers take an action. And this action is, it can be between 0 and 1. The interpretation of this action is the support that's provided by the receiver to the media policy's preferred platform, right? So as I promised you, the audience is going to be heterogeneous in terms of their opinions and attitudes. And here's how I'm going to capture this. I'm going to allow for this audience to have heterogeneous priors about the state of the world. So I'm going to allow basically this probability that the receiver assigns to state being 1 to depend on R. And I'm going to denote it by PR, right? So if you start with a very high prior, it means that initially you are very optimistic about this policy. If you start with a very low prior, you are very pessimistic. I'm also going to allow this cost of support, which is the preferences towards policy, to depend on the distribution, to vary with the audience, right? So I'm going to allow different people to have different costs of support. So essentially, there is going to be like a 2-dimensional distribution, which is going to be captured by this density FCP. And this is the density of both costs and priors, right? So this is everything that we need to know about our receivers. And each receiver's payoff is going to be the following. The receiver takes an action between 0 and 1, and this is the payoff that you receive after you take this action. What does it mean? Well, you can always take action 0 and get a payoff of 0. If you take the action 1, what you are going to get is the payoff that you are going to get is theta minus CR, right? So CR is like the cost of policy. If it's super high, you don't want to support it. And if your posterior about theta is sufficiently high, then you want to support it, right? So specifically, the posterior that you have about theta needs to be exceeding CR, right? So this is like the critical threshold that you need to exceed, right? If CR is high, you are more demanding, your attitudes are stronger. Okay, so this is the parts of the receivers. What about the sender? Well, the sender also has a prior that I'm going to denote by PS. And the sender's payoff is the total amount of support that the policy gets, right? So it's just a linear function, you know, like I'm just aggregating all the supports of people. So essentially, the more supporters, the better it is, right? So this is going to be like the payoff function of the sender. All right, cool. We're okay with this. So this.
Arda, I have a couple of questions just to clarify. The PS and the PRs, they're all common knowledge, I assume.
They are all common knowledge.
And I mean, this would have been equally fun if you assume that AR was either 0 or 1, right?
Correct. Effectively, it's binary actions. Yeah.
Yeah. Okay.
Correct. Okay, so I mean, this middle part of this thing, this model slide tends to be a little bit difficult to keep in mind. So what I'm going to do is to show this in a graph, which is going to make it easier to sort of convey. So essentially, what I'm thinking about here is that is a two-dimensional graph. On the x-axis, I have the prior. On the y-axis, I have the cost. So every single citizen here is represented by a dot, right? So your prior and your cost. And essentially, I'm thinking about a distribution over this unit square, right? So there is one more thing that I want to point out, which is the following. So initially, if you do not have any information, of course, if your prior is higher than your cost, you are going to support this policy. Otherwise, you are not, right? So if you just think about this like 45-degree line, people below it are going to be ex ante supporting this policy. People above it are going to be opposing the policy. So we are basically starting with a figure like this, right? So this is absence any information. Therefore, there is this ex ante remark. There are supporters and opponents of this policy, right? So this is going to be important because I'm going to be talking about who the parties and media targets and etc. And we are going to be referring to this idea about being an ex ante supporter and an ex ante opponent. All right. So what does the media do? The media is the sender here. It sends a message from a large enough set. For today's talk, let's just restrict this set to be a binary choice. Just take my word that under the distributions of opinions and attitudes that we consider, this is going to be enough for our purposes. And what does the sender do is that the sender commits to a public communication strategy, right? So basically, what is a public communication strategy in the setup? It is a strategy that specifies a distribution of messages under each state, right? So basically, it's just two numbers because we only have two states and two messages here. Essentially, a public communication strategy is two numbers. The first one is sigma 0, the second one is sigma 1. Sigma 0 is the probability of saying that things are good, when the state is 0. And sigma 1 is the probability of saying that things are good when the state is 1, right? So if I just give you these two numbers between 0 and 1, I would be telling you everything about the media strategy. Without loss of generality, I'm going to be assuming sigma 1 is larger than sigma 0. Otherwise, you can flip the messages and obtain the same type of results, right? So what happens here is that the timing is the sender first commits to a sigma. Everybody observes the sigma. The message is drawn according to the sigma. There is full commitment, so the sender cannot change the message. And then each of the citizens see this message, it updates, and then each of the citizens act, and then we receive our payouts. Okay. So here is another obligatory slide that we have to have whenever we have a Bayesian persuasion paper, right? So because the first thing that bothers people about these type of setups is that, you are making a full commitment assumption, how restrictive it is. So let me just put talk like a couple of, maybe like 1 minute about like the meaning and the justification behind this commitment assumption, right? So the first observation that I want to make is that you can somehow relax this commitment assumption, and recent papers actually do that. So there is this brilliant job market paper by Chao Lin and his co-author. And so he is saying that, hey, look, maybe you do not have to have full commitment, but you might allow the sender to have certain types of deviations. Not all deviations, but certain types of deviations. And this is what he calls the undetectable deviations, in the sense that, like the frequency of good message must match, but you can choose a different policy as long as it generates the same frequency. And then he shows that under certain conditions, actually this full commitment assumption goes through. If you allow for these type of deviations, like this still becomes the optimal policy. One of the conditions that he considers is state-independent preferences by the sender, which is what we have here. The sender just wants to maximize the support regardless of the state. I want to just point out that, with heterogeneous priors, at least, it becomes a little bit cumbersome to think about these like undetectable deviations, because we have heterogeneous priors. Everybody expects a different frequency anyway, so you have to, be careful about defining it. But a certain sort of version of it goes through. You can also think about, just thinking about embedding this full commitment assumption in a richer setup. This is what Masha is doing, her recent paper, Masha Titova. So basically, you can think about a verifiable disclosure setup with a richer state space, which gives you the same, this like full commitment assumption. So this is like one way of relaxing this commitment assumption. The second justification that I'm going to give is more sort of particular about this media interpretation. You can think about this policy as the media committing to a certain editorial policy, right? So the media does not, set up every single news by themselves. They set up an editorial policy and then it delegates the decisions to editors and reporters, right? So this is like the type of justification that's provided by Gelbach and Sonin in their 2014 paper, Journal of Public Economics. So that's like another sort of way to think about it. The third one, which is actually something that I find like really interesting and intriguing. You do not actually have to think about this, like the equilibrium that we construct as like a one-by-one description of the reality, but maybe it's a description of the best case scenario for the sender. And the sender doesn't even have to be the partisan media in the setup. You can think about a politician, right? So basically what we are answering here is the following question, according to this interpretation. There is a politician who could hypothetically design a media landscape, right? So what type of media landscape would you design if you could design any media landscape? This is like the best case scenario for you. And we are sort of describing this environment, right? And taken through this lens, you can also take this model to this like models of media capture, censorship, information manipulation, and etc. But you can also think about these like what these like media sources mean, and etc. And I'm going to come back to this later when I'm discussing the results.
Okay. So can I digress here a little bit? I wanted to ask you about this first earlier about, are you going to present or frame it as a welfare results or efficiency results? Normative question. You are talking about good policy, bad policy. A bit more kind of clarification on that, maybe.
Yeah. So one of the results that I'm going to show you is basically about the following. So you change the distribution that we started with, and the media becomes less biased, right? So there is a certain normative appeal to this type of comparative static, which is, once it's less biased, people have access to better information and they make like, better decisions. But
when you say this ideal media landscape, this is from the point of view of the politician, not necessarily.
Of the politician, yeah. So basically, Thanks. So what I'm saying here is, there are several ways to interpret this. So the first one is that if you are facing a more polarized electorate as a politician, actually you enjoy having a more informative media. It's less disturbing to you because there are a lot of extremist people in the society, and there's only one way in which they're going to pay attention to the news and perhaps vote in your favor, right? So it's not a welfare result in that sense, but it's it's relevant for some things that we might be saying. I have like one more sort of interpretation along those lines, but let me just wait until I present the result. I think it's going to be more clear. All right. Okay, so what does the media do in this setup? So let me just give you like maybe like one or two slides about this media's trade-off, and then we're going to talk about the optimal policy. Well, basically what's happening here is that let's just fix a media policy and think about who pays attention to the news, right? So let's just fix sigmas, and then what happens here is that, of course, each receiver is sophisticated and they're a Bayesian updater. So they see the message and then update their priors, right? So their posteriors are given by these like Bayesian updating formulas. And there are two things that I want to emphasize about these formulas. So the first one is that, of course, one of these messages send your prior to the right, the other one to the left, right? So, your prior is in between. So basically, your posteriors become something like this. You started with a prior PR, right? And then you either have a posterior to the right of it or a posterior to the left of it. And because sigma 1 is larger than sigma 0, basically, when you hear the good message, you become more optimistic. When you hear the bad message, you become more pessimistic, of course. So this is the first thing. The second thing that I want to emphasize is that if you start with a higher prior, these things are like monotonic in the sense that if your prior is higher, then this point is also higher and this point is also higher, right? So everything is sort of shifting to the right if you start with a higher prior. This is like the beauty of Bayesian updating. It's predictable in a certain manner. So what I want to point out is the following now. When are you going to pay attention to the media? You are going to pay attention to the media effectively when the media's information has the potential of changing your actions, right? So if you remember, you change your actions depending on whether your posterior is above or below CR, right? So basically, if you are a person who is like this, you know, you have a high posterior and a low posterior, right? And then CR is somewhere in here, then you are paying attention to the media, right? This is one possibility, but there are other possibilities. You can be a super optimistic person, in which case your posteriors either jump here or here, and maybe your cost is here. And in this case, effectively, you are not paying attention to the media because you're optimistic in either case, right? Either you're super optimistic or your cost is super low, right? Or a third possibility is that, of course, you can have something like this. You start with a low prior and your cost is super high, so you don't pay attention to the media because you're going to resist this policy anyway, right? So basically, because of this shifting property of these priors that I've just described, now there are three possible cases, and you fall into one of these categories. And I can actually characterize how high or how low your prior has to be within each of these categories. And this is a proposition that sort of dissects this society into three groups, right? So if your prior is in between these bounds, then what you're doing is that as a receiver, you are paying attention to the news. Your action depends on the message. If your prior is super high, then you're always supporting this policy. If your prior is super low, you are never supporting this policy, right? Let's go back to this figure. So basically, this is how these bounds look like, right? So if you are in between here, you are a complier. So this is like the terminology that we chose to hear. It's like, so basically, you are complying with the message. If your characteristics as an individual is around here, it means that you are an always supporter, right? And it makes a lot of sense. These people are super optimistic and they also have like super low costs, right? So they are like very extreme supporters of this policy, right? And if your prior and cost is around here, it means that you are super pessimistic and the cost is super high, so you don't support this policy, right? So this is the sense in which I am trying to formalize this insight that I gave you before, which is, you know, more moderate people, which are people around here, are more inclined to follow the news. Given any policy, this is going to be the dissection of the population into these three groups. And these people in this like middle eye are going to be the people who are going to be paying attention, right? Now, what the media does is that the media chooses a sigma, and the sigma basically changes these boundaries. So what I want you to think about is the following. If you choose a more informative policy, I can show you that these bounds are extending. So this range of compliers is extending actually. And if you set a fully informative media, then everybody is a complier, right? So it extends so much that it sort of eats up this whole unit square. And if you set up a non-informative policy at all, this sort of set of compliers shrinks, and then it becomes a measure zero set, right? So people just go with their priors, right? So basically, this is the trade-off that the media is facing. So if you set up a more informative policy, you attract more compliers, right? You gain people in this margin of, you know, paying attention to the media. But the cost of it, of course, is that sometimes you have to tell the truth and sometimes the truth is bad. So you're going to be losing people who are paying attention to you with some probability, right? So this is like the main trade-off that's deriving this media's choice in the setup, right? So if you become super informative, more people pay attention to you, but you know, they might support you with lower probability, right? Okay, so how do you resolve this trade-off? That's the next thing that I'm going to...
Before you go on, here the picture makes it look like everything is uniform, but actually your F distribution can be very biased, right? So it could be that you're going to favor, you know, sending message zeros over ones. There's no assumption of symmetry in
exactly.
Right? So it's not
you're
just,
going to see in a second. Yeah, go ahead.
It's not just informativeness, but it's also which way the distribution of cost and priors is biased. That's going to matter a lot.
Exactly.
Right?
So you might choose a policy such that, for instance, like there are no always supporters, depending on the shape of distribution. You can also, you know, take this part of the boundary up, and then, you know, in that case, there are no never supporters. And depending on the distribution, either of them can be a case.
Sorry, one more question. no informative policy, zero information, this means both sigmas are the same?
So when you basically have zero information, yes. So that's the case where sigma 0 is equal to sigma 1.
And then that's the 45-degree line, both curves.
That's the 45-degree line. So this set of compliers shrinks so that these lines, you know, become
regardless of the prior distribution. Thank you.
Correct. Correct. Okay. All right. So how do you resolve this trade-off? Let's think about this. Now, it's so we understand the trade-off, but of course, as you just pointed out, the distribution of priors and costs matter a lot for this solution. And it's a complicated thing, like a two-dimensional object. So we're going to have a certain approach to, you know, solve this problem. And our approach is going to be basically towards imagining a representative receiver rather than a continuum of receivers. So what do I mean by a representative receiver? So here's the type of approach that we're going to adopt to sort of characterize the optimal policy. Let's just take a random posterior of the sender, right, mu. And I am going to think about the sender's total support for this posterior mu, right? So I know that how everybody behaves and how they update and etc. So I can back out the total support. And then what I'm going to do is that I'm going to imagine a representative receiver with the same prior as the sender, right? So basically, I'm going to sort of lose this heterogeneous priors aspect by choosing a certain representative receiver. And then what I'm going to imagine is that this representative receiver is providing the total support just by herself, right? So it's just depending on her posterior, she chooses a certain level of support, right? So basically, once I do this, I can draw a value function. And once I draw a value function, we know how to solve these problems. You can go back to Kamenik-Genskov and then concavify this thing and then, you know, characterize this optimal policy. So that's like the type of approach that I'm going to do. Now, what does this representative receiver do? It provides the full support. What is the full support, the total support that the media receives? Well, here is again another beauty of the Bayesian update, right? So let me just think about the following case. So let me just think about this representative receiver who starts with this prior PS, and then the representative receiver's posterior mu. And then let me think about another receiver with this prior and this posterior, right? Here's the great thing about Bayesian updating. If you have two people with two different priors, and if you know about one person's posterior, you can actually back out the other person's posterior, right? Because it's a certain mapping with certain predictable sort of properties. And here is the mapping that I have here, right? So it's coming from Alonso and Camara, who is sort of having a single receiver, single sender model. Eleonora, do you have a question or? Okay. So what I can do is that I can, you know, back out this other receiver's posterior, and I can do it for every receiver. And I know that this other receiver is supporting this policy as long as the CR is below this threshold, right? Mu R, right? So the posterior has to be above the cost. So I can sort of define this function, which is a threshold of cost. Everybody below this cost is supporting this policy under this posterior. I can repeat this exercise for every single mu. And now I can do, what I can do is that I can sort of back out the total support, right? And now what I can imagine is that, so this is now a function, which is a function of the posterior. But what you can imagine is that there's a single receiver rather than multiple receivers that is sort of taking this action that I have on the right, and when the posterior is me, right? And now you can write down the value function and etc. and back out this optimal policy. So here's the thing about the value function. So if you just look at this function, you can verify that under very mild conditions, this function is increasing in mu. So higher posterior means more support, right? It's not surprising everybody is more optimistic when the sender is more optimistic. So their support increases. It also satisfies V0 is equal to 0 and V1 is equal to 1. In other words, what I have given you is just a CDF, right? So once you have a CDF, you can take the derivative of it and find the PDF, right? So let me just take the derivative of this thing and call this thing H mu, the PDF, the virtual density. Why is it a virtual density? Because we started with other objects and then we collapsed it into another object. And people like to call them virtual things, right? So this is the virtual density. But the beauty of this virtual density is, first, I have successfully managed to sort of collapse this like two-dimensional statistic into a single statistic, right? Which is like a one-dimensional object. It's just the density. And the second one is that it has an intuitive interpretation in the following sense. H mu is the density of receivers who are just indifferent between supporting this policy or not when the sender's posterior is equal to mu, right? So now we can think about, this like virtual density and what it means to be a polarized society, what it means to be a society with a lot of moderate people, right? So if H mu is like very thick in the middle, what we can have is that, there are a lot of people who are moderate in the sense that their opinions can change easily by these moderate posteriors. If it has a lot of fat tails, you're going to see in a second, that corresponds to like a very polarized society. But this is like, my way of reducing this problem into a single dimensional object, which is a density. And now we are going to use this density. And in order to use this density, I'm going to start by some inspiration from the political science literature that has been thinking about these things. So this is a figure from Fiorina and Abrams' 2008 review paper. And in this paper, they talk about polarization and they say that, hey, look, even with a single dimensional distribution, there is no easy way to define what polarization is. But here is a basic thing that we can agree on. We think that the top distribution corresponds to a polarized distribution and the bottom distribution corresponds to a non-polarized distribution, right? Now, what I'm going to do is that I'm going to interpret these distributions as corresponding to several different cases of the virtual density. So basically, if your virtual density looks like the one below, then you have a very non-polarized society, which is what I'm going to call a unimodal society. And this is like a very highly polarized society, right? So let me start with this like unimodal non-polarized distribution, right? So basically what I'm having here is that what I'm thinking about here is that the virtual density is single peaked, where the classic definition of single peaked. So what I want to imagine is that this corresponds to a society with many moderate citizens, because again, H mu is the density of citizens who are just indifferent between taking the media supported action or not. Here's the proposition. If the virtual density is single peaked, then the optimal policy has two important features. So the first one is that the sender says that things are good whenever things are actually good, right? An implication of this one is that, of course, that whenever the citizens hear that things are bad, they deduce that things are actually bad with probability 1, right? Because whenever things are good, the sender says that things are good. Whenever the sender will hear that the sender saying things are bad, or things have to be terrible, right? Another implication of this one is that the ex-ante supporters are now actually paying attention to the media under the optimal policy, which is you're going to see in a second. But first of all, why does the bad message fully reveal the bad state? Well, we have a single peak density, right? And again, the density is the derivative of this value function. So if the density is single peak, the value function is first convex and then concave, right? So your value function looks like this. So the optimal policy, how does it look like? This is what we know from Kamenika and Ganskov. The optimal policy sends the posterior to either here or here, right? If you start with a prior like this, right? Well, which means that you either sort of confess that the state is bad, or you send the posteriors to a place that's high enough so that, they are here. Well, this is the reason why we have fully informative bad news, right? And once you have fully informative bad news, I think, so Francesco, this is a partial answer to your observation earlier. So everybody to the bottom of this 45-degree line actually pay attention to the news, because even when you are here, right, there is a chance that paying attention to the news sends your posterior all the way down to 0, right? So these news are always informative and valuable to you. So all of these people actually pay attention to the news, right? And this is the second part of the proposition. And this is the reason why the media is targeting the supporters, right? So if you're an ex-ante supporter, you are effectively targeted by the media, because the media's policy is designed to attract your attention, right? Even when you are an extreme supporter, right? So this is how the optimal policy looks like when you have a unimodal society. Now you can imagine where it's going to go. with the highly polarized society, it's going to be the mirror image, right? So if you have a single dipped virtual density, then the good message is going to be fully revealing the good state, right? Now you are going to say that things are bad whenever things are bad, which means that the media is going to be rarely saying things are good, but it's going to be very informative. And now all the opponents are going to be paying attention to the news. Why? Well, again, draw this picture. Now this is a single dip density. So its integral is first concave, then convex. The concave closure looks like this, right? So the posteriors are either sent to here or to here. So when you hear the good message, your posterior jumps all the way up to 1. Because of this, even when you are an extreme opponent of this policy, like if you're here, you find it worthwhile to pay attention to this media source, right? So this is a qualitative difference between the two types of society, highly polarized and non-polarized societies. The media acts differently, the biased media acts differently in these two societies, right? So why is there such a difference in a highly polarized society? Well, intuitively, I think this is the story of what's going on. There are very few moderates in a highly polarized society, right? So there are there are a lot of people here, and there are a lot of people here, right? So the sender, if the sender wants to, be this media to be useful, the sender has to provide some information, right? Some extreme amount of information, otherwise you don't pay attention. Well, you can provide information in either way. You can provide very informative bad news or very informative good news. But if you provide very informative bad news, then you risk losing the supporters, right? Because these people who are extreme supporters then are going to pay attention to the media. And you don't want to lose them because there is a lot of them, right? So what you do is actually going into the opposite direction. You sort of create this media source that says all the bad things about the state of the world, but very rarely says something good. And then it actually convinces these extreme opponents to pay attention to the media because that rare occurrence of good news is very, very informative, right? Now, Max, here's an answer to your earlier question, and it's, I think, a very speculative policy, but I think it's representative of a logic of something like this. So if you are Donald Trump, and if you are facing a very, very highly polarized electorate, right? So here is a type of media landscape that works in your favor. There is a New York Times that only liberals watch, and they watch very thoroughly, right? So, and it's beneficial for you because that's effectively the only way that you can convince this body of liberal people, right? Because New York Times, all of the times it's going to say all the bad things about Trump, but once every 6 months, it's going to say, maybe this thing that this guy is doing is not a terrible thing, right? And in that case, all of these liberals are going to be saying, hey, look, I mean, maybe, I'm going to be supporting this policy. And that's the only way in which you can actually change the opinions of these people while making sure that your own supporters actually don't pay attention to these news because they are very strongly in your favor. So, they don't believe in those things. So again, it's a speculative story, and I'm not saying that this is a description of what's going on, but again, that's an implication of this interpretation that I have, right? Okay, so one last thing that I want to do before I finish is to give you this result, media bias result under polarization. And what I want to do here is that I already sort of told you about two extreme cases, single peaked and single dipped. Now, what I want to do is that I want to be able to compare two single peak distributions within each other, right? So I want to polarize the single peak distribution. And in order to do that, I need a partial order to compare the polarization of two densities. And essentially what we had to do is that we had to come up with a partial order by ourselves because, this is the one that works essentially. And it took us like a lot of time to figure this out, but I think it's a very actually intuitive measure of polarization. So here is the measure of polarization that I'm going to be discussing. Take two single peaked virtual densities, and a similar sort of definition applies to single dip densities. Take two single peak densities that satisfy the following equality. There is an H1 and there is an H2. And H2 is equal to H1 to the power of alpha, where alpha is a number that's larger than 1. And there is a kappa here. Kappa is just a normalization factor that makes sure that things integrate to 1. So don't worry about it. It's not important. What matters here is the alpha. So what I'm doing here is that I'm taking a distribution H1 and I'm taking it to the power of alpha, where alpha is larger than 1. So in the parts where this density is larger than 1, this transformation sort of makes these parts even larger, right? So it exaggerates the larger parts and it sort of downplays the smaller parts, right? And because this is a single peak density, what's happening is that I'm exaggerating the middle part and I'm downplaying the extremes, right? So this is the manner in which I'm polarizing this distribution. So in this case, of course, I'm non-polarizing this distribution. I'm having a density that's less polarized than the original density, right? So here there's a figure that, you know, hopefully makes it clear, right? This is the transformation that I'm applying. I'm taking this distribution and I'm applying this transformation for different values of alpha. And for higher and higher values alpha, I'm getting a less polarized distribution, right? So this is, I mean, we basically had to come up with this measure. So I don't know, but I mean, so it applies to actually, this partial order applies to actually a lot of, you know, distributions. So essentially we discuss it in the paper, but you can take two symmetric beta distributions and rank them in order of polarization. You can take truncated normals and rank them in terms of polarization based on their variance and etc. So anything with an exponential part within the density, basically, I think it goes through, okay? So the other nice thing about this polarization order is that very nicely, it tells you that uniform distribution is more polarized than any single peak distribution, which is what you would expect, right? So it's like, you know, a very flat distribution. Okay, so what I show here is that if you make the distribution less biased, then you are gonna, if you make the distribution more polarized, then you are gonna actually have a less biased policy. What do I mean by a less biased policy? As you already remember, under single peak distributions, sigma 1 is equal to 1. And if you have a more polarized distribution, then this sigma 0 is decreasing, right? So the probability of saying that things are good when things are bad are decreasing, right? So you are having a more informative media when the society is more polarized, right? So intuitively, what's happening here is that we are polarizing the distribution, right, according to the metric that I just defined. What's happening here is that it's taking some people from this middle slice and it's sending people to the extremes, right? And because of it, for any given policy, now there are fewer people paying attention to this policy and more people who are not paying attention to this policy. So these people who are already paying attention to you have lower measures, so you care less about them relatively. So you want to extend this middle slice a little bit, right? And that's the sense in which, you know, you want to appeal to more people and increase your outreach, right? So the proof of this theorem is basically like a straightforward application, I would say, of, you know, this implicit function. So, you know, we calculate this mu hat and then we show that it moves predictably. I think what's interesting is that it's just this like polarization measure and making sure that it works, because it's not an easy thing to find something that works, even though we have an idea that actually, you know, more diverse and more polarized preferences tend to push senders towards more information revelation. One final thing, you can sort of do the same thing for single dip densities, you know, just polarize them in a similar manner and get the same idea. You have a more polarized virtual density, then you have less biased media, right? So here's the figure that I want to show you. This is basically putting everything that I've shown you together. So this is like an illustration of what I have shown you. So let me just start with a single peak density, right? And under this single peak density, what is the optimal policy? I have already shown you earlier in this talk that the optimal policy says things are good whenever things are actually good. And then when things are bad, it mixes, right? And let me just apply this transformation and make this distribution more polarized, right? So here's another single peak distribution that's more polarized. And here, as you can see, I'm more truthful and I'm less biased, right? So here I'm coming and I'm approaching to this boundary of single peak distributions, which is the uniform density. When you have a uniform density, any policy is optimal because your value function is linear, right? So, you know, we cannot, so basically the sender is indifferent between any information revelation policy. So here I cannot tell you, you know, so I mean, I cannot compare you what happens to the left and to the right, but if once I jump to the left, now I know that the policy actually looks something like this. Sigma 0 is 0 and sigma 1 is positive. And if I keep polarizing it, again, the bias keeps decreasing, right? So to the left and right of uniform distributions, it's difficult to compare. It's actually impossible to compare the informativeness of these things because you're talking about different animals. But you know, like overall, once you move towards the left, towards a more polarized distribution, you are making the media less biased. Okay, so one last thing, we are all worried about the consequence of polarization, right? And one part of this worry is that maybe we are inherently worried that this is going to create a vicious cycle, right? It goes like more polarized electorate might create more polarized media, and then it polarizes people even further. And I think like if you sort of have some sort of like a behavioral aspect of following the news, I think these worries are actually very well grounded, right? There is a recent paper by Helios Herrera and Ravi Sethi that sort of sets up a model where people have some behavioral bias and shows that, you know, people follow the wrong source of media, wrong type of media, and make the wrong decisions, and etc. But what I'm showing you here is that maybe with a strategic media and sophisticated citizens where everybody is rational, there is a force in the opposite direction. So maybe this is like a silver lining of polarization, not a single silver lining, but at least like, you know, here is a force that's going to break maybe this vicious cycle at some end, right? So we are inherently optimistic people, I guess. You know, this might be a reason, and here's the last speculative thing that I'm going to say. So Marcus Pryor, again, in a review article, he says that there is no firm evidence that partisan media is making more ordinary Americans more partisan. And again, very speculative, but at least I have shown you a theoretical channel in which the media is forced to be more informative rather than polarizing people even further in the face of polarization. All right, thank you very much. 50 minutes we said, and I took 51 minutes, but I think we started 1 minute late, so maybe.
Thanks a lot. This was very neat, I have to say. So thanks a lot for the presentation. Now let's move to Q&A session. If there's anyone who wishes to ask a question or clarification or give a comment, please let us know. Unmute yourself, just straight ahead. We are going to stop the recording at certain